Alright, so simply put, I'm just gonna solve some difference quotient stuff. They're like very basic ones. So like we have x squared, square root of x, and 1 over x. So these are pretty basic ones, I would assume they are. And so yeah, I'm gonna solve them using the difference quotient and yeah, the definition of the derivative right there. Okay, let's get it go. So we have x squared. So what we're gonna do here is simply just do not f, what, for x plus h squared minus x squared, so yeah, like that, over h. And like, of course, for limits, you don't want, like, of course, oh my god, you know, you're gonna divide by 0, but that's okay, because this h is gonna get canceled out anyway, so we don't gotta worry about him. He's always gonna get canceled out. We don't gotta worry about that guy. It's all good. So we have this too, so we're just gonna, you know, make that to them, because pretty much x plus h squared is equal to you know, x plus h times x plus h, you know, that, so this is equal to this thing right here. So yeah, this is equal to all that. That's great. So I'll just show you. We're gonna FOIL it out. So we have this x right here. We're gonna do the FOIL. So boom, we're gonna go that one. So we have x squared, and then we have this right here. So then we have plus xh. Then we have h times the x right here, which gives us another xh. And then we have the h here going to the other h here, which gives us h squared. We have two xh's. Very cool. We just have x squared plus x, not xh, what? X squared plus 2xh plus xh squared over h. Yeah. Very, very cool. We also have to have our limit as not x, h approaches 0. Pretty sure. I'm still inexperienced in math, so like, yeah, you know, just gotta make sure. And so yeah, I also forgot to write, we have the minus x squared here, because, you know, we gotta write that part of the definition, right? And we also have it right there too. I just forgot to write it down. So once we have that written down, it's like, okay, we take a look here. All right, we have the x squared minus this x squared right here. So these are just gonna go bye-bye, and we're left with 2xh plus h squared over, holy crap, I'm like writing super diagonally, but yeah, you know, stuff happens. As you can see here, we can factor out an h from that. Very sick. Let's do exactly that. So I'm actually gonna move this up a little bit, so it's a little less out of the way. And yeah, we're gonna just factor in h. So we got h, 2x plus h inside, and then on the bottom, let's just move this h out of the way because I don't like it being there. Okay, well, we're gonna have to deal with that now. And then we have, yeah, the h at the bottom. These h's cancel, which gives us 2x plus h. And then of course, because, oh, that was a little far. And of course, because we have that limit as h approaches 0, we're just gonna plug that into this h here, which means 2x plus 0. Now that's just gonna be a 0. This will just be 2x. Very, very cool. Yeah, so that's number 1. Okay, so we're gonna find the difference quotient of this. So that'd be f of x equals x, not x squared, what? Square root of x. There we go. I'm tired. Okay. So we're gonna rewrite the difference quotient formula. So that'd be limit as h approaches 0, f x plus h minus f of x over h. So we're just gonna put this, slam it into there, slam it into there. Pretty simple. So now we just have square root of x plus h minus square root of x over h. And let me just say, I've only taken classes up to algebra 2. So no pre-calc, no trig, no college calc, I don't know. But yeah, I've only taken up to algebra 2. So I'm just like restating or retelling what I've seen and heard from other people on YouTube, specifically YouTube. Okay. So to get rid of these the square roots and whatever, these goofy square roots, we're going to use the difference of quotients, which not difference of quotients. What the heck? Difference of squares. There we go. That's money. So the difference of squares pretty much states a squared minus b squared is equal to parentheses a plus b and then a minus b. So you get this. And so we're just gonna not find the conjugate, we're gonna use the conjugate. I'm gonna delete this so it's just not in our way. And so we're going to use the conjugate, which is pretty much just this, but that's a plus sign now. So we're just going to times this by, almost screwed up there, x plus h plus square root of x. And also we have to do this at the bottom too. So we're going to do a little bit of copy paste because I don't want to write that again. Booyah. Like nothing happened at all. Sick. Anyways. So pretty much what we'll get is x plus h minus x over h. Yeah, over h. Okay, yeah. Over h, and of course we have this that entire thing too. So we're gonna write that down real quick. Okay, that was really bad. That was really bad, but we're just gonna forget about that. Square root of x plus h. Oh my, dude, what? Whoa, bro. What is that? That looks ugly. Okay. So all this, right? We got these two x's, right? So we have that x minus that x minus x right here. So we have that minus that x. So these are just gonna go cancel, of course. So they're just gonna cancel. And we are left with h at the top. Yeah. So we have h at the top right here. So of course we can just factor out these two here. Forgot that in parentheses. We can just cancel these two h's, right? So then we're just left with 1 over square root of x plus h plus square root of x. And because we're going to the the limit as h approaches 0, that means that h is just 0 in there. So it pretty much just means square root of x plus square root of x, which just equals 2 square root of x. So overall, we got 1 over 2 square root of x. That's our final answer right there. Booyah. Got it. All right, this is my fourth time going through this. Turns out I'm really good at fumbling. Anyways, we're going to find the difference quotient of the rational function 1 over x. Pretty cool, pretty simple. So let's get this going. So we have our difference quotient formula up here, and we're just going to plug in x plus h to the x and then the minus x right there too. So we have 1 over x plus h minus 1 over x. This is all over h. We are subtracting these two thingamabobs, all right? And so we need the same denominator, which they don't have the same denominator. This guy doesn't have a plus h, so we need that. So the way I'm going to do this is that I'm just going to times both sides by x plus h and x. All right, pretty simple, I think. X plus h. And so x plus h times 1 over x plus h just means that, these two are going to cancel. And we have the x, the 1 over x times x. These x's are just going to cancel too. Which means that this x plus h is going to go at the top, and it's also going to go at the bottom here. And this means that this x is going to go at the top, and it's going to go at the bottom here. All right, pretty simple. Should look something kind of like that. Very cool. Kind of looks like a like a dead guy or something. Like, you know, like he's like, he's tired. He's real tired. He's a tired guy. Anyways. So we have x and then times, I mean not times, minus x plus h. There we go. I can English. I know how to speak English. Then we have our h times our x plus h times our x. So we have this negative here, and it's pretty much like a negative 1, right? So we're just going to distribute this negative 1 into this thingamabob right here. So we get negative x and we get negative h. So I'm just going to, you know, erase the parentheses like this. And now we have a minus h instead of a plus h, because negative 1 up times h is just negative h. So we have these two x's, x minus x, that's just going to be 0. So these guys are going to go bye-bye. Forget about them. They're nobodies now. And now we have negative h and then this h. We can just divide these out. So, you know, these guys are going to go bye-bye. They're all gone. Which means we have a negative 1 over, x plus h times x. Just going to, you know, fill that in a little more. I want to make sure this is centered. And because we have a, you know, limit as h approaches 0, now our h is just 0, okay? So h is just 0, which means we just have x times x. Okay, let me do it like this. So negative 1 over x times x, which is just, you know, x squared. That's what that is. So now, yeah, we're just left with 1 over x squared. That's our final answer right there. Booyah. And I guess another way that we can show that that's true is like the power rule or something. I don't know. I just want to show that off because why not? Why not? I'm an inexperienced math guy, so you know, I just want to show off some skills, right? Even though it's just a power rule. So we have nx, n minus 1, alright? So that's our like power rule. Let me zoom this in a little more so we, you know, don't really get a... Okay, well, you can still see the work that we did for the difference quotient, but it's whatever. And let's see. We had 1 over x. 1 over x is also another way to write x to the negative 1 power. And so we are going to move this down here. As this says right here, it's like, boom, you just move your n down there like that. And so we have negative 1 times x is just a negative x, right? All right, yep, just a negative x. And we, you know, we have to minus this number by 1, just like it says there. So we're going to minus that by 1. Very cool. And so we have negative x to the power of negative 2. And because of that, we're just going to move this entire thing under, because, you know, like this is just negative x to the power of negative 2 over 1. So we're just going to flip these around. So this is going to go to the bottom. And so now we have negative 1 over x squared, which is, hey, it's crazy. That's what we got right there. Holy moly. It's the derivative. It's almost like the difference quotient is the definition of a derivative. Holy moly. Yeah, that's all I got to say. If I fluffed up anywhere, or, you know, any advice you have to give, if anyone's watching, for some reason, if anyone's watching, then yeah, thanks, and you know, have a good night. See ya.